to make sure that you are aligned with the Biobank business objectives for value creation. After that, an operation plan is required to be in place, and to prepare the operation plan, usually you need to focus on the three aspects, which is people, processes, and technology. By people, for sure, we need, they are the ones who do the tasks described in the process. So onboarding the right people is really crucial. And this starts by identifying the key employees with the right skills, experience, and attitude for each job. By a process, we mean the actions that are combined to produce a particular output. Technology, for sure, is the tools that the people can use to implement those processes. So choosing the right technology that supports the operation is really crucial. We'll start with the first aspect, which is people. There are, as you may know, I'm sure you know, certain sourcing model for getting or onboarding the right people to support your function, which is the insourcing model. So in sourcing, we mean personnel is fully managed by the organization. They are full-time employed. Salaries and benefits are all coming from the organization budget. You need to make sure that training is being provided to those people and ensure that they are up to date with the latest technology. Outsourcing is another model. It's all about having the service or the personnel managed by a third party. Here you have less managerial control as the service is being managed by a third party. So you need to make sure that you have clear SLA in place. Co-sourcing, it is more into partnership model, and it's not managed through rigid contracts. There is more flexibility in terms of getting the required resources from your partner. The main function within the IT, based on our experience, it is basically infrastructure operation, application development, data management, IT services support. We found that it is good to have someone who looks after the cybersecurity and information security compliance, if possible, to segregate the duty between the IT manager and the security compliance. So sourcing for those functions within IT, you can mix it between the different models, which we described earlier, and depends on your, for sure, the operation plan. When it comes to the processes, there are some frameworks and standards available, and it is known. I believe my colleagues in previous sessions also, they shed light on ISO, ISMS standards. So for us, we found that the ITIL framework helped us in building the service strategy. So by using this framework, we were able to establish our service catalog, define the service level agreement between IT and other functions within the Biobank, the service operation, incident management, release and deployment management, change management, configuration management, service reporting, and for sure, continual improvement. Being ISO ISMS 27001 certified, we found that using this standard is very useful in applying security controls. These security controls, there is a long list of security controls that the organization can apply. It's provided in the statement of applicability of this standard. You need to establish the information security policy, also to have a risk management process in place, Software and hardware asset management, physical and asset and system access management. And for sure, backup and restoration process is crucial since you're dealing with data and data is your asset. And again, to establish a set of KPIs that should be measured on a regular basis to know where you are standing and how to improve your services as IT function. When it comes to the technology aspect, for sure, here infrastructure is one of the main aspects in technology. And determining infrastructure or planning for infrastructure aspect, you need to consider the security and the governance requirement. You need to make sure that you are compliant with the regulations and laws within the country. So you may need to consider certain security tools, appliances, like multi-factor authentication, firewall, antiviruses, SIM solutions for monitoring purpose. Also, you need to think of the IT site, where it will be located. We will talk about this soon. For sure, you need to determine the services and storages that you require to operate. So you need to identify the different type of servers that you may require, like system monitoring servers, application servers for some enterprise resource planning systems, or mobile applications if you have web servers, database servers. If you are providing email services, then you need to ensure that you have for sure email servers, file and print servers, FTP servers, service desk, and other special purpose servers, depends on the need. Staff need to communicate, and you need as an organization to exchange information, maybe with other entities. So you need to make sure that you have tools required for telecommunication and interoperability. So for sure, you will need networking, Wi-Fi, internet services, MPLSs, and data exchange between organization, VPN for secure connectivity to your local network to support the business operation whenever needed. And of course, you will require endpoints like PCs, telephones, peripherals like printers, barcodes, scanners, cell phones, maybe audio systems, network devices, backup solution. And for sure, you need to make sure that you have licenses and support agreements to ensure the high availability of your services provided to the other functions within the biobank. Of course, all of these decision depends on the cost and budget availability within the biobank itself. So talking about the IT sites options, there are different options like on-premise and off-premise, infrastructure as a service, and cloud service. So for on-premise and off-premise, it's almost the same when it comes to the pros and cons. The differences between the two options is that in the offshore option, your actual servers or data center is physically located in a service provider who is specialized in data center management. So the pros for these two options is that you have full control over your assets and data privacy. So for good or bad, you will be responsible for that. There is a clear ownership of the data resides within the organization. It is a good option for organizations with sensitive data like biobanks. And ensure more compliance with regulatory requirements as you have full control. The cons of this option is the cost of hardware and tech refresh. Each time you need to make sure that you are catching up with the latest technologies. So you need to have enough budget for that. It has impact on your personnel. So you need to make sure that you have enough IT personnel to manage the infrastructure. and it puts higher responsibility on privacy and security on IT department. The infrastructure as a service, here you don't need to think of any tech refresh. It is managed by the service provider, so it is somehow cost saving, and it is more scalable and fast to respond to the business. And also these companies usually they assure a high availability of high rates like 99.9%. The cons is security control. It is managed by the service provider. Also, the software maintenance part will be managed by the client or the organization itself. So there is still an overhead of personnel required to maintain those systems for the organization. Also, it depends on the service provider ethics. So you need to make sure that there is a strict service level agreement with the service provider. The trend nowadays is cloud solutions. So there is, as they claim, there is pros for this option. The easy scalability, less operation cost, as they claim. You have rapid access to latest technology, and also from hardware and software perspective. So you have access to GPUs maybe if you need, and latest technologies when it comes to machine learning, artificial intelligence application, and these stuff. The cons, on the other hand, is really tricky. So you need to, those service providers have a complicated shared security model. So you need to really pay attention to the roles and responsibility and security aspect and controls that you apply. Somehow the organization will be locked in, so it's not really easy to migrate the workload from one cloud provider to another. The pricing structure is also complex, so you need to make sure that only the services that you are actually using is you subscribe to, and you make sure that it is utilized well. Less flexibility than the on-premise environment, because the service provider, they choose the many of the configuration, and you don't have that choice, so you lose somehow the control. Still, you will require the cloud skilled staff to retain within the organization. When it comes to cloud, countries, they may have certain regulations. They may not allow for their data to be in certain countries because these countries have strict privacy laws. So it is worth paying attention to these points. In Qatar Biobank, we made a choice to have the on-premise setup. So our infrastructure is divided into two networks. One is internet facing, and the other one, which is holding our participants' data, is in an air-gapped network, whereas there is no internet access to this network. Also, we implemented the high availability for our infrastructure. So we have a primary site and a secondary site in two different locations. It is active, so whenever any issue happens, the primary site, directly it will activate the secondary site without impacting the business operation. So the rationale for our decision is basically to have more control over the privacy of our participants' data, and it gives us more control over the system's availability and security matters. Another aspect in technology, for sure, is the applications or the tools that you need to provide to your to other departments within the biobank. So you need to identify those functions within the biobank, conduct meeting with those functions to understand their business requirements, and then think of the systems or applications that serve them best. We found that this tool application architecture is really useful. So you identify different functions and then place on the tools that will be used by those functions, and then identify how the data may flow between those systems. This is an example of our application architecture for Qatar Biobank. So we have identified different functions and different systems or tools used by each function. And as you can see in the arrows, here it shows how the data is being flowing between the different systems. At the same time, we have an interface for integration with third party, like the governmental hospital here in Qatar. So we send some samples to that hospital to do some analysis and send us back the results. And this communication is handled through a secured platform where the data exchange happens. So the decision, I call it a 1 million question. It is the how to acquire those tools, buy or build. So there are different aspects that you need to consider in deciding either to buy or build those tools. It depends actually on the problem that you have in hand. Is it a unique or a novel? So out of the box solutions is not suitable for the existing problem. Maybe you are thinking to commercialize your in-house developed solution in long run. You may have enough fund to support the in-house development, and you have really reliable and expert source of team who can do the actual development either through outsourcing or in-house team. Also, you may think of this option if you want to avoid vendor lock-in. And also, you need to be more agile to respond to the business changes, and if you have a really mission-critical data. Buying a solution is driven by the following aspects. If your problem is really common and you find 80% of your requirements is available in the solutions available in the market, the solutions in the market has APIs that allows you to integrate with different tools you have. And also the vendors gives you the possibility to customize the solution and provide you with fast bug fixing and frequently updates. For sure, these vendors should have a flexible and clear service level agreement to ensure that you have enough support required. So in Qatar Biobank, what do we have as core systems? I think the starting point is with the participant registration and relationship management. So we have a system built on Microsoft CRM. I believe our colleagues in yesterday's session, they talked enough about this solution. Then after recruiting the participants, we start collecting the data. So we have a clinical information system for this purpose. And for sure, we are collecting samples. So those samples is being operated by lab, and we are providing them with a laboratory management system. Since we give the feedback to the participants, so we have a medical review system in place. And all of these systems, the data collected eventually in the data warehouse. So it is a centralized, curated data warehouse that we can use to provide data to our researchers and for decision-making also to our management here. From here, I will hand over to my colleague Samir to take you more details about how we manage the data here in Qatar Biobank. Yes, Samir. Yes.
Thank you, Amina, and good evening, everyone, and welcome to the session. So in today's session, we are going to see what is the data management, why there is a need of a data management, okay? And we will be seeing some of the essential components of the data management, okay? And the practices that we follow in regards to these components. So what is the data management? The data management is the practice of collecting, organizing, protecting, and storing an organization data so it can be analyzed for business decisions. A well-designed data management system mainly focuses on the component that defines the accuracy, consistency, security, and the availability of the data. So we have some of the essential components that are required for building an effective data management system. Some that are listed here are data architecture, data classification, data sharing, data analytics, data security, the backups and administration, and finally the data availability. Now, why there is a need of data management? First, we will understand that the data management, basically is effective when it gives you the improvement in data processing efficiency and supports a better decision making by providing a reliable and secure source of information. It involves the various activities such as data quality management, data security, data integration, data warehouse, and data analytics. Now, the motive of having the data management in place is to ensure that the data we have is accurate, consistent, and available when needed. The better the data management, the better the productivity in the business. So further, we will be elaborating more on these components, and we will be seeing what are the practices we follow in our organization. The first component what we will be discussing is a data architecture. Now, the data architecture is an essential component of data management. Data architecture in a data management is designed and organization of your data systems. It involves normally the process of creating a blueprint, or we can say a document of how the data is stored, organized, accessed, and used within the organization. Generally, we can just outline it as it's a data flow map. It is showing an overview of your data. Now, how to build this data architecture? It is formed by dividing it into three essential models. The conceptual model. This model is represented in the form of entity relationship diagram, where we design a a relation between the entities and the attributes. The second is the logical model. This model represents the structure of the data in more detail than the conceptual model. It shows how the data is stored or into the tables, columns, and relationship. Data types like, for example, in our system, we have, different types of data coming, XML, what would be the XML data coming inside, various sources of information. Then we have image data, the image is like retinal. Then we have a PDF reports. So here we will be basically discussing on how we can store and the data into our database system. So there are some kind of a data types available. What are those data types? These data types may be XML format in a where binary max. So these all are defined in this logical model. The third is a physical model. This model represents the physical design of your database system. This is where your actual implementation of your database system takes place. So here what we define is this is specific to particular hardware or your software environment. So what would be your software? What will be your database platform? Whether it would be a Microsoft SQL or an Oracle. So this is where you define your hardware specification and the software that you will be using. Then gathering these three models later to form one data architecture. Now the goal of having this data architecture is to show the company's infrastructure how the data is stored, processed, and is used within the organization. Coming to the next component, this data classification. The data classification is the process of organizing and categorizing the data based on the level of sensitivity, confidentiality, and criticality. Now, it helps us to identify the level of protection we need to put in place for each type of data and implement appropriate security measures. So there are different methods of for data classification. Mostly in the organization, it is used as a combination of categories. But here we will be discussing some of the the categories we have documented, and we follow this in our organization. The first is the PII. that is a personal identifiable information. So in personal identifiable information, this category has the information that uniquely identifies a participant. Now, for example, his telephone number, his national ID number, his health card number. So this is directly related to an individual. So this is categorized as a PII information. The second is a highly sensitive data. Now, this category has the information related to his geographical locations or a date which is directly related to an individual, like a birth date or a discharge date or an admission date, etc. Then we have a third category as a sensitive data. Now, this category has an information related to the participant's measurement, his health history, or his lifestyle. The fourth category what we have is an internal data. So all the information related to our our system or internal operations, such as who has performed the test, what test has been done, has been categorized as a internal data. Then there is a public data. So all the information that is available on the public source, or that can be easily available. There are no such restrictions imposed on that. That is mentioned as a public data. For example, how many number of participants has been recruited till date. So such kind of an information is categorized in the public data. Now, what benefit we have in classifying this data? The classification of this data helps us to de-identify the data using we having a de-identification policy, so that we can pseudonymize or de-identify the data before we share it with our partner institutes or researchers. So we will be coming to the next component, that is a data sharing. Now, data sharing is also one of the essential component of the data management. Now, it is the process of making the data available to other users or a system for their use. So normally we have a procedures to be defined for data sharing within the organization or with the partner institute. Okay. So if we discuss it from our side, we have some SOP defined where we have a certain guidelines where we follow to share the data. I have listed some of the the guidelines that we shared. So we will be just checking that. The data is exchanged with the authorized users only, the first. And all the files that we shared are encrypted. Now the files can be an Excel file which is password protected, or it can be on an external media, which is again encrypted with a BitLocker and password encrypted. Now these passwords are shared separately, via separate email. Then we have the data sharing over FTP, secured FTP. So now we have a FTP configured which is secured, so that we ensure that the data that we have is in motion is secured. Now the data is removed from the FTP after the once the data has been exchanged, or after a certain period of a time. So the data will be available only till the limited period of time. Then we have a separate communication channel where we have only source or destination devices enabled and restricted, so that there is no other ports or channel open for this thing. This would be a dedicated channel. And we also have an antivirus system installed on the FTP server. So this antivirus basically scans all the incoming documents that we have. This is to avoid any kind of vulnerabilities or threats that are during when we receive the document. So first it is been scanned. All the documents that we received are scanned, and then only it is taken inside a internal system. For now, data analytics. Now this is also one of the essential components of data management. Now this component basically is built on top of that your data layer. Now the data analytics, this is the process of examining, processing, and interpreting the data to extract insights and patterns that can inform decision making and business value. It involves uses of various analytical tools and techniques to explore and understand a data set, identify the trends and patterns, and derive insights that can be used to improve the business performance. So this is basically, this component basically helps you to get the insights out of your data. So this component will be very well explained in the further session by my colleague Sneha, where she will be showing some demos on this, some dashboards on this. So I will be moving up to the next component. Data security. Now, the data security in data management is the measure taken to protect the data from unauthorized access, use, disclosure, or a destruction. It involves ensuring that the data is stored, processed, and transmitted in a way that minimizes the risk of data breaches and unauthorized access. Considering the data security, we have implemented some of the features that, some of the features, and we have enabled and configured it so that it minimizes the risk of data breach and unauthorized access. So I have listed some of the features and we can go through it. The first is the integrate logins with Windows security. Since Windows is known for their robust security, such as authentication for its encryptions, for its access control, and when Windows are further integrated with the Active Directory, we have the benefit of having a single sign-on. So we have integrated our database logins with the Windows security. This gives us the benefit of enhancing our security of a database system and thus reduces the minimize the risk, minimize the data, the loss of your data breach and unauthorized access. The role-based access control. Now the we also have implemented a role-based access control on the database on the system level. So this role-based access control ensures that the users are only granted access to the resource that they need to perform their job, the job function. So we have, in this case, we have a granular control on to provide the access on the object level, which can be later revoked after the completion of the job. So this reduces the risk of data breach, the insider threats, and the other security incidents. Then we have a database audit and log activity. Now we have enabled the audit on the database and on the object level. So enabling on the database audit on the database level gives us control to check and monitor like what all is happening on the database level, like DDL commands like drop, alter, and the DCL commands like data control, the grant command, the deny, the revoke. So all kind of the commands that affects the database related activity is monitored in the audit, database audit. Then we have an object level audit as well, where we check where we have audit in the form of triggers. So the triggers where we change whatever changes are happening on the data level, it is being recorded in the logs so that we can, in case of there is any data breach or if there is we need to check or revise, we can go back to the log and we can check. Then we have a log activity. Now this log activity records all the the operational tasks like the backups that are going on, what the backups are passed or failed, successful or not, so these are recorded, and it also records the incoming connections that are accessing the database. So we are getting all the incoming connections that are trying to reach the database, whether it's failing or it is accessing. So we do a routine, checkup for this, going through the logs to identify if there are any source of IPs that are not recognized or not authorized, and they are trying to access it. Then we have a routine patch upgrade activity. Now patches are known for to address the vulnerabilities and the security fixes. It also has the performance enhancement and the bug fixes. So we have a patch activity, where we apply latest security and patches on our database system to keep it, on a stable and a performance to get a performance benefit and to have a maintain a stability of the system. Data backup and maintenance. So the database backups and maintenance are a critical component of a data management. So this practice helps us to ensure that the data is protected and available. So here are some of the common practices for the database backups and maintenance. The database, first we will discuss on the database backups and the retention policies. So we have a database backup strategy in place to ensure that the data is recoverable in the event of disaster, such as hardware failure or a security breach. The backup strategy follows full, incremental, and the cumulative backup, which helps us to recover the data at any point of time. These backups are further taken on the tape or a physical copies. So to achieve this backups, we have a solution, a net backup where we have automated these backups, And this solution does not only restrict to take the backups for the databases, but it also gives us the flexibility to move these backups to the tape. So in a form of physical copies. Then we have retention policies. Now, the retention policies helps us to determine how long the backups are kept and how and when they can be deleted. So this ensures that we have to have a timeline, like we have a certain period of backups available, and also it benefits us, like what the in terms of the storage consumption doesn't move out. So this retention policies, we have this the replacement of the old backup existing with the new backup. Then we have a DB backup validation procedure. Now the backups that we are taking, we need to ensure that these backups are valid and can be used at any point of a time. So since we have a chain of backups and the long backups, this needs to be tested. So what we do is we have set up an environment where we define a cutoff date for the backup, and we take these backups and we try to restore it on the test environment. Then the backup validation is done based on how we based on the accessing the data. So the data is validated inside, and we are at the same point of a time, we also restore the application on that particular date, and we try to test the compatibility of the application with the database. So in this way, we test both the backups or the validation, the data also, and also the application compatibility. Then we have a DB maintenance activity. Now we have a regular maintenance task, including checking for and repairing any corruption that happens in the data, optimizing the data performance, and updating the software patches to ensure. This task helps us to ensure that our system is running smooth and efficiently, and that the data is protected against the data loss. Now this is the one of the critical component, high availability. Now the high availability refers to the ability of a system to continue functioning and provide the access to the data in the event of hardware or a software failure. Now this means that even if the one of your component of the system, such as a network or a hardware, fails, the system can automatically and quickly switch over to an alternative component to continue serving requests without any disruption. So we can achieve this high availability on, if we see the picture we have, there are two nodes. We have the primary replica and the secondary replica. The primary ones are one which will be serving the request, read and write, and the secondary will be on the read only. So the data that is replicated from the primary to the secondary will be real time. Each node has a independent storage, so that we have a redundancy on the storage part as well. So there are different options available for the high availability. But since our core systems are on SQL Server, we have a SQL Server always on configured. So what benefit does it gives to us? So first is combining the HA and DR. So this always on provides both high availability and disaster recovery, because it has an actual live copy on the secondary server that makes us the data available at a real time. So within a few clicks, like we can turn our database from HA to DR. Failover of multiple database. Now we have a set of dependence databases. Like for example, for our cohort studies, we have a dependent databases. So having this databases in a set of a group for a failover helps us. So for example, there is a corruption in one of the database. So all the set of the database that is under the group is having the set of the database are failed over to the another server, so that the application continues to work without any disruption. Then there is a also a plus point of having an automatic failover, where there is no manual intervention required and your services are moved automatically without any disruptions in the application. It also assures that zero data loss and protection. That means if we are having our system in a synchronous mode, the synchronous mode means the data is written first on the secondary server, and it acknowledges to the primary server, and then it is written to the primary server. So in case of failure, the data is already written on the node 2, the secondary node. So in case of failover, there is no data loss, and we will be in a the data, there won't be any loss of the data. Then we have an independent storage. So in the other features that we provide, that is provided by the SQL Server, is the Windows cluster that has a common storage. So in that there was a drawback. If the storage goes down, there won't be any failover, and your complete architecture will go down. But what we have in the SQL Server always on is there is an independent storage. So there will be a duplicate copy on each node. So we are having a duplicate copy on the secondary node. So in case of their storage goes down, also there will be a failover, and we have already a live copy existing on a secondary server. Then this feature also gives us the ability for automatic page repair. So if there are any page corruption happening inside, so it will try to repair it automatically. Active use of secondary server. So now in this, the secondary server is not just a copy, it is a read-only replica. So what we do is we use this server to offload some of our queries. For example, this secondary server will be in a read-only mode. So we will be using it for the reporting purpose or for the maintenance, like checking the integrity of the database. So this kind of an operations are moved to the secondary server. This gives us like a kind of an active server. And the last one is to enhance the performance. So when we offload these queries, it takes some of the resources and a usage from the primary server to the secondary server. So this gives us the benefit of enhancing the performance. So this is what the high availability feature we have in our thing. That's it from my side. I think I will hand it over back to Amina. So she will be taking ahead to challenges and opportunities. Thank you.
Thank you so much, Samir, for very excellent and fruitful session about the data management. Well done. So talking about the challenges and opportunities, for me as an IT professional working in IT sector for 20 years now, my past experience was not related to research sector at all, so it was my unique experience. And I have to admit that it is really unique and not repeatable experience at all. So moving from standard IT industry to IT and research, we found that there are really challenges in IT for research, and in Biobank in particular. So we found that there's really shortage in Biobank tailored systems. We are used to ready-made solutions that we can customize usually and just plug and play. Here it is really difficult to find the solution that fits 80% maybe of your requirements. It's always, there's gaps that you need to fill. Budget constraint in funding IT investments. This is another challenge that we always work on solving it and be innovative. Continuous changes. Researchers are really highly demanding people, so you need to satisfy them somehow. So this pressurizes IT a lot in making sure that the balance is maintained between fast response to the business changes and the data privacy and the quality that you have. So in spite of these challenges, we believe that there is opportunities. So like establishing a biobank standardized systems that can be utilized by biobanks around the world. Also, it gives an opportunity for in-house development and strengthening your in-house team to build the systems that fits the biobank need, and it gives more flexibility to respond to the business changes, and also gives you more control on data privacy, considering all the factors that we've covered in our session today. That's it from our side in the first session, and we are open for any questions you have.
There's no questions in the chat, so if anyone would like to ask a question out loud, now would be the time.
So it seems that we were very much clear, so people don't have a question, or they were really, the session maybe not useful much.
I thought it was a wonderful session. Let me ask a question. So you talked a lot about your data management and analysis systems, and I'm
Yes.
interested in how those work outside of the QBB. So have you worked with other organizations in a federated analysis system at all? In other words, doing analysis, taking the data, pushing it up to the cloud, letting another system come in and run an API on the data without the data actually leaving.
Actually, no.
No?
We didn't reach this stage, and there is really high demand in this aspect. People want to use the data and to share it for international, maybe research collaboration. This is really in our mind, and it's in our pipeline as well to have it done. But we need to make sure that the foundation is really there to make this happen without jeopardizing, the privacy and confidentiality of the data we have.
Thank you very much for that answer. That makes perfect sense. Any other questions from anyone online that they'd like to ask? Either type it in the chat or speak out loud now. I think both the presentations, as you say, were very clear and concise, and so there just really aren't any questions, which is a good sign. But let's take a 5-minute bio break now. Let's make it 7 minutes, and we'll reconvene at the top of the hour for the second part.
I urge everyone to just wait for the next session. It is really interactive and very useful, so don't miss it.
Thank you.
Thank you.
A break till the top of the hour, then we'll start again.
Thank you.
Okay, everyone, let's get started with the second part of our presentation today on the IT systems of the Qatar Biobank. We have two presenters that will be taking us through, I believe it's some live presentations on how the system actually works. Our first presenter is Fahad Mahal. Fahad has over 20 years of professional experience in healthcare IT, both as research and clinical settings, and he currently works as the Clinical Information Systems Specialist at the QBB, where he has been instrumental in implementing various research data collection management systems, including LIMS, CIS, PACS, CANTAB, Cognitive, and the various clinical device softwares. And prior to joining the QBB, he worked at the Ministry of Health in Oman, where he played a key role in the rollout of the electronic medical record system across the country. He has a master's degree in software systems and a Bachelor of Engineering in Computer Science, and is certified as CPHIMS and a Prince 2 practitioner. Our second presenter is Snetha Priyachandran. Snetha has over 18 years of professional experience in information technology sector in the healthcare, research, digital media, and management consulting domains. She currently works as the data warehouse developer at the QBB and joined the BB in 2018. She's accomplished several things in her career. The latest and most significant was the QBB data warehouse, where the solution aggregates data from a wide range of sources, including structured and unstructured data, and developed business rules in collaboration with researchers and scientists. Thank you very much for both being with us today, and I will turn it over to you.
Thank you, Mrs. Kaur. Shall I share my screen?
Yes.
Please.
Hello, everyone. Welcome and thank you for joining us today. My name is Fahad and I'm a Clinical Information Systems Specialist at Qatar Biobank. During this session, my colleague Sneha and I will be sharing our experience in implementing our core systems and data warehouse in Qatar Biobank. I'll be focusing on the application systems, and then later Sneha will take over and talk about the data warehouse and analytics platform. We hope you will get some insight from our presentation that you can use in your own work. So one of our core application system is our CIS, or Clinical Information System, which is used to manage participant data collection during their visit to Qatar Biobank's assessment clinic. As shown in the diagram, once the participant arrives in our assessment clinic, he or she is first registered in the system and a unique participant ID is generated. After the registration, consent is obtained from the participant, and after consenting, participant has to go through a set of interdependent stages to complete their visit. These stages include health questionnaires, the biological samples to be collected, and physical measurements. And all these stages are based on the study requirement. The questionnaires asked could be different based on studies, or the samples collected could be different. So we have studies where we don't collect samples at all. And once all the data is collected, the visit is concluded. If the participant is contraindicated for some measurement, he or she is called for a revisit to complete the remaining measurement. The solution that we are using now to manage the workflow is called Onyx. Onyx is an open source and free application from Obiva project. Obiva project is part of the Maelstrom research program at McGill University, Montreal in Canada. Onyx is a web-based solution. It's developed using Java technologies. And it's a solution built for research institutes like us to collect data during participant visit to the assessment centers. In Qatar Biobank, Onyx was implemented in March 2016 and it's been used for the last 7 years. We selected Onyx After evaluating many commercial and open source solutions that were available in the market then in 2015, we prepared a list of must-have features and nice-to-have features and evaluated the solutions against it. Though there were many solutions that could handle participant registration concerning any question, we could not find a suitable solution that managed the clinical device integration in a simple and straightforward way. Integration of these devices was an important or must-have criteria for us, as we do not want our staff in the clinic to enter the data manually, which is error-prone. And some of the commercial solutions that we evaluated were like too big for us, for our environment. And though Onyx was not meeting all of our requirements, it was meeting most of our core requirements, especially on the clinical device integration and easily defining dependency between different stages. Also, the application workflow of Onyx is almost similar to our workflow in the clinic. And before making the final decision to get confidence, we tested the application in our own environment by configuring a small study. We also connected the development team from Oviva. They were very supportive and helped us in the initial setup. As I mentioned, Onyx out of the box doesn't meet all our requirements. Like doesn't support multiple studies and multiple visits in case of longitudinal studies. So we decided to implement it in different phases. So we had our first release in March 2016 to manage our cohort study. Then we had only one study. All the questionnaires were configured and all the devices were integrated with Onyx. After going live, we had some challenges related to the performance. But as the solution is an open source, we were able to go through the source code and identify the issues. And we had a minor release to fix those issues. And then we had a couple of new studies introduced. And in 2019, we had a major release to introduce multiple studies and visit support in Onyx, along with some usability improvement features. Currently, Onyx is configured to manage 6 studies in live, and during COVID, we were able to set up Onyx in a short time to handle our COVID study. So it's been a successful journey. And as I mentioned, integration of our clinical devices was one of our must-have feature, because it streamlines the processes, it saves time, it reduces human errors, and at the end, it reduces the data quality issues. So we have integrated all the devices with our CIS. We have different devices with different integration capabilities. Some support unidirectional communication, some support bidirectional communication. Some is over TCP/IP, some are serial ports, some are based on file systems, and some devices support standard messaging, some is just CSV files. So on the left side, you can see some of the devices that we have integrated with us. We have stereometers from Sika, we have Y-coder, we have some radiologist devices which is integrated to our packs, and then we have ECG. All these devices are integrated. We have only 2 devices which is not electrical, like measuring tape and hand grip. All the electronic devices are integrated. And on the right side, you can see the application systems that we have integrated with our CIS, like our Catalyst links for collecting for sample collection. It's integrated with our CRO, our booking or PRMS system to share the appointment information. And it's integrated with our medical review system for sharing the lab results to the medics. And it's integrated with Cantab cognitive testing. And we have a PACS. That's also an open source PACS, and CIS. All the radiology devices are integrated to our PACS. Also, we have integrated with external hospitals Cerner system, Millennium system, for getting our participants' demographic information from the National Patient Index. So now I will switch to, I'll give you a quick demo of our Onyx system. Please bear with me when I move to application. So this is Onyx. It doesn't look flashy, but it does the job too. Once a participant arrives in the clinic, so we register them as I mentioned. The registration screen can be easily customized based on the study requirement. You can see that. So the details to be captured can be customized. And once participant is registered, a unique participant ID is generated based on the study requirement. I have created some visits for the demo purpose. And after the registration, participant is accompanied to the clinic. So I will open the. So once in the clinic, once the staff open the participant file, they can see all the questionnaires and clinical measurements to be collected during this particular visit for this visit type. Here you can see there are only 6 stages, and for this participant, this is for our cohort study. You can see more, and the stages dependency between these stages can be easily configured. You can see that here the bioimpedance is not active because the participant is contraindicated to bioimpedance. So the participant has a metal implant. So now I'll show you the consent module. So the consent can be easily configured based on the study requirement. You can prepare as a Word document, convert it into a PDF, and then can be uploaded into Onyx. So this consent is for this particular study, and we can capture the response from the participant, and all this information is extracted and it's stored in the database, so that we can use it in upstream processing. And it is integrated to, we can use our signature pads to capture the signature from the participants. So you can see here, once a participant is consented, the remaining the questionnaire stages are active because there is no the dependency was with the consent. So I'll open a questionnaire and show you. So we can define easily different type of questions in Onyx. It can be a single option, or it can be multiple choice questions, or it can be matrix style questions. And we can define dependency between questions. For example, here, if the participant answers no, the next question will not be asked. And the questions can be either in English or in Arabic. Arabic was not supported by out of the box by Onyx, but then we customized it. So, and the questionnaires can be posed. So and the clinic and the physical measurements, it's all integrated with our devices. So once the measurement is done, system will automatically capture the results from the devices. So these are the main functionalities of Onyx. So now I'll switch back to my presentation. So now I'll move to our LIMS, which is another core system in Qatar Biobank. What is LIMS? LIMS is our laboratory information management system, is used to manage the collection, processing, storage, and distribution of biological samples. LIMS also tracks the entire life cycle of the sample from collection to usage, and also it ensures that the chain of custody of each sample is maintained. LIMS also ensures that the workflows are reproducible and traceable, and ensures that the processing adheres to the study protocols to avoid deviation from the protocol. We are currently using 2 applications to manage the sample tracking. Catalyst is our new LIMS, and iLIMS is our legacy application. Both the systems are in-house developed. As LIMS is one of our key systems required for a biobank, we decided to invest in developing a solution in-house. We had looked into the commercial solution, but we could not find any suitable one that could be easily customizable, that could be customized to meet our workflows and required integrations. The Catalyst, Summation Catalyst is our new solution, which is completely developed in-house by our team. It's a web-based solution developed using .NET technologies, and Catalyst will be eventually replacing our legacy iLIMS application. We are implementing Catalyst in a phased approach to gradually phase out the legacy system. Phase 1 is already live, and the plan is to completely replace legacy system by 2023. And iLIMS is our legacy system, again, which was completely developed by our team in-house. The first version was released in March 2016. We started iLIMS small, and then the system evolved as Biobank, Qatar Biobank also evolved. So iLIMS is a client-server application, so it cannot be accessed from browsers or iPad. This is one of the reasons that we decided to develop a new system. Just like in CIS, we have integrated all our laboratory instruments with our LIMS. On the left side, you can see some of the instruments that we have integrated. Again, the integration is done based on the capability of the device. Some are file-based and some are API-based. On the left side, these are the devices. On the right side, you can see some of the application systems that we have integrated our LIMS to, like our CIS for sharing the participant demographics. It's integrated with our medical review system to share the test results. It's integrated with the Cerner PathNet system, which is used in an external lab where we send our samples for analysis. Catalyst places the order electronically in Cerner PathNet. Once the order is, and once the result is released in the external lab, we immediately get the results. And the integration is completely based on HL7 messaging. FQC is functional QC software from Rutgers University, and we have integrated to exchange data with the system. Research portal and temperature monitoring systems are not currently integrated, but we have planned to integrate it in future release. Before going to the demo, I quickly go through the main features that a LIMS should have to manage the process in a biobank like ours. Like as study setup, for example, as we have multiple studies, LIMS should support creating multiple studies and visit types. And based on the study requirements, LIMS should be able to define the sample collection protocol, processing protocol, and the plan for storage. And for reproducibility, changes to these plans or protocols shall be version controlled. And LIMS shall have the capability to manage participant registration, consenting, and withdrawals. In our case, we did not develop a module for this because it's integrated, our LIMS is integrated with our CIS. And for sample collection, system should have the capability to define the type of kits to be used and the containers to be used based on the study requirement. And system should document the collection details when the sample is collected in the clinic. Sample can be received from our clinic collected during participant visit, or we can receive samples from external entities. Like it could be a QC sample or proficiency testing sample from external organization, or it could be a sample from external research for storage or for storage or processing. Sample processing, and in this sample processing and in this, based on the study requirements, we should be able to define the processes to be done on the samples. Some studies might not require any processing, as sample can be directly stored in the freezer. But for some studies, there could be multiple processes to be done prior to the storage. And after completing the process, system should have the capability to manually or to capture the processing data, or if it is integrated, system should automatically get the data from the devices. If any test is to be done on a sample, system shall have the option to define based on the study requirement what are the tests to be done and where the study is done. In our case, some of the tests we do here in our lab, and some are referred out to external lab. So LIMS should have the features to define the test, place where it is done, and capture the result from the instruments or from external lab once the result is released. And in storage and retrieval module, we should be able to define different types of storages used for storing samples, like freezers, liquid LN2 tanks, portable freezers, etc. And system should support storing the plates, samples, or reagents. Request management system is for managing the selection, reservation, and shipment of samples based on the request from researchers. For streamlining the process, LIMS can be integrated with the research portal so that once the request is approved, it can be immediately notified to the lab. Temperature tracking, ideally LIMS should be able to track temperature of a sample from collection to distribution. When we open a sample's temperature graph, there shouldn't be any gap on the graph. So to achieve this, all the temperature data loggers and monitoring systems should be integrated to our LIMS. Inventory module is to manage the consumables used in the lab, such as reagents and containers. So now I will switch the presentation. I'll give you a quick demo of our Catalyst LIMS. Yeah, this is the homepage of our Catalyst LIMS. On the left side, you can see the modules available based on the user permissions and roles. Now I'm logged in as an admin user, and on top you can see some common functionalities, like we can define notifications, and it can be assigned in a user role, and once they log in, they can see the notifications, and then some themes, and you can change that. So I'll start with the sample reception. So we have two UIs for sample reception. One is for internal sample, receiving the sample which is collected from our clinic, and one is for external. Because for internal samples, we just need to capture just need to scan the sample ID, because all the information related to the sample is already collected from the clinic. And then after verifying this, lab technician can just receive the sample. External samples can be from different sources. It could be from external researchers, or it could be for clinical analysis from other hospitals. or it could be QC samples, or it could be proficiency samples. And the samples can be received one by one, or if the sample is received on a plate, all the samples can be received all together. And sample dispatch module is, as I mentioned, some of the tests for samples, we are referring out of samples to external lab. So this module is for managing that. So once the order is, so our LIMS places the order electronically in the external lab, external partner system. And once the result is released from there, we receive the results immediately. So here users can choose the samples to be dispatched, and they can mark it as dispatched. Sample storage module is for managing the freezers, liquid nitrogen tanks. Users can define freezers with the different structures, like they can have a fridge with just one compartment, or they can have freezers with multiple compartments and racks. And storing and assigning plates or samples as you see, have to just, and they can see the plate information directly here. And for storing a plate, they just need to scan the plate number. And removing is just, they can remove it from the storage by clicking on the remove button. And work list module is for managing the work list of individual users based on their pending processes. So they can see all the pending samples to be processed for this particular study, and then they can add it to a particular run. So, and then plates is for managing the plates, different plates. Users can define different plates with different layouts and can assign samples to it. So in benefit of time, so I will stop the demonstration now, and I'll hand over to Sneha to explain about the data warehouse and data analytics platform.
Okay, Sneha, are you ready for your presentation?
Thank you for the detailed presentation as well as the system demo. I am Sneha Chandran. I am currently working as data warehouse developer in Qatar Biobank, and I joined Biobank in 2018. Now that we have seen the various clinical and laboratory information collection systems, which collect operational data in Biobank in the transactional layer. Now we will move on to the data lifecycle, how we can use this data in our analytical layer, where we have the business data warehouse, which is in-house developed in the Biobank, which links all these data, curates them and loads into a central repository. And this data will be used for the reporting as well as the informed decision making by the decision makers. As in every data warehouse, the starting point of a warehouse is the various data sources from which the warehouse have to extract data. In Qatar Biobank, we have a large number of data sources from all the various business processes of our various studies and visits. We have a few legacy systems which were used by Qatar Biobank in the initial period. Then also we have the currently used live systems. And we have to extract data from all these heterogeneous data sources to provide to our researchers. As you can see, we have structured, semi-structured, and unstructured data. Majority of our data can be classified in the structured and semi-structured category. In the structured category, we have around 18 SQL Server databases, which are from our clinical information systems, and also some are legacy systems, and also We have two Oracle system databases. So all these forms our structured data sources. And we have semi-structured sources. These are mainly the application of the Java properties and XML files. These are used in our clinical information system, where we have a large number of survey questionnaires from which we are collecting data. So all these questions and the various answer options resides in these properties files used by the application. And to use this data in the analytical layer, we need the details of these particular attributes. So in our warehouse, we have a need to extract data from these application source files. And also we have device proprietary XML files from ECG Mortara device. These are also a data source from which we have to extract raw data as well as ECG waveforms to be used to release to our researchers. Regarding the electronic medical records data which we receive from the hospitals in Qatar, these we are receiving in delimiter separated files, and then we have proteomics and metabolomics data received in CSVs and spreadsheets. So these all forms our data sources. Regarding the unstructured data, we have PDF reports where we have data available in natural language to be extracted, and also we have MRI DICOMs as well as retinal images which needs to be pseudonymized and also released to the researchers. One of the challenge we have in all these data sources is the enormous number of data elements all these sources have, which are of interest for our researchers. Before moving into the design of the data warehouse, we will have a quick overview of how the data extraction started in Qatar Biobank in the initial period. When we reached a particular milestone of participant recruitment, for example, 3,000 participants are recruited or 6,000 recruited, we request for the snapshots of all these heterogeneous data sources, which we just now saw. And then in the IT, we develop various SQL manual scripts to extract data from these sources, which are of interest. We transform this data and present them in Excel files. We also conduct a peer review of the developed scripts as well as the data. And we release this data in Excel to the data extraction team so that they can use for project-wise data extraction to provide to our researchers. As you can see, this is a very time-consuming process, and we used to take around 4 to 5 months to finish one particular master data extract. So the main challenge, as I have mentioned, is the time, and also there is high probability of error because we are updating the scripts every time. And rework is required for every new master data. And there were the data is stored in Excel files with manual versioning, and we do not have a single point of truth for our data. This is a very risk for the business. So to mitigate these challenges, the strategy implemented by Biobank is for the data warehouse implementation. In Biobank, we have implemented an in-house developed data warehouse. So in this slide, you can see the high-level architecture of our warehouse. On the left, you can see the various data sources, which we have already discussed from all the heterogeneous sources. And also we have external genomics data, which also forms our data source. As you can see that we have a ETL processing. We are using Microsoft Stack for our analytical layer. We are using Microsoft SSIS integration services engine to extract the data of interest. We apply various business rules and load the data of interest into our staging layer. And then we apply again the second level of our business rules to transform and load this data into our integrated data warehouse. And we also keep a archival level layer of all the historically processed data for future analysis if required. Once our data is loaded into the warehouse, we have a reporting and analytical platform where we have the data extraction reports, which is using the Power BI report server as well as Microsoft Reporting Services report. where we have data reports for per business processes. This is used for extracting and providing data to our researchers. We also run ad hoc data queries for subject selection in our warehouse, and also we use it for analytical purposes. Now we will have a quick overview of how we have implemented the data warehouse in Qatar Biobank. It is a phased approach. Once we decide to start a particular phase, we do a requirements analysis, and we do a capacity planning, and we will be considering the data sources. We will be data sources of interest in this particular phase. Once the sources are identified, we will do a source analysis. For example, we have various proprietary sources coming from these instruments through which we are collecting the data. So in most of the time, we need to be in touch with the vendor who is providing these proprietary instruments to understand the data structure so that we can use it downstream. Once the data source study is completed, we will proceed with the conceptual data model. We will do a logical data model if it is required. If this particular source is going to communicate with the existing module, or if it is a completely new source, we will directly proceed into the physical data model, where we create the low-level tables and the DB objects. Once this phase is completed, we will move into the ETL development, where we will apply the various business rules provided by our business users. And finally, we will load the data into our warehouse. Once the loading completed, we will do an ETL functional testing, where our ETL packages will be tested by the peers. And also we will do a rejection analysis. In our rejection, we will also capture which business rule this particular data has failed. So, and we provide this rejection to our business users so that they can accept the rejection, and also they will verify our ETL testing, and then we have the user acceptance from the business. Once this stage is completed, we will go live with the particular module and also the particular phase of the data warehouse. Here you can see our conceptual data model currently implemented in the Biobank. The heart of our conceptual model is a participant. So in the middle, you can see that is particular study participant. He is participating in which study, and all his attributes as a person. We collect this particular entity, and we also have for this particular participant, what are all his study attributes, what is his visit, interview, and consent level information, which is required in a warehouse. And around the participant, as you can see, we have various clinical questionnaires, lab results, and also we have the samples collected from them. And out of the samples, we make the aliquots, which are all the major sample types we have. Then we have the electronic medical records and the omics data centered around a participant. Now, we have in our data warehouse, we have already completed the main phase, which is the phase 1, and also we are going to complete phase 2. As of now, we have loaded around 35,000 data elements in our data warehouse. Here you can see that we have around 2,200 survey questionnaires collected, and also various from the clinical measurements, we have around 2,200 data elements. And from the electronic medical records of diagnosis and procedures and medications, we have around 27,000 data sets. Here for the diagnosis codes and procedures, we consider each procedure as an element. And also we have around 1,500 metabolites and proteins information loaded into our warehouse. And also we have around 200 biomarkers of lab results as well as loaded. So what is the value we have of all these data elements loaded in our warehouse? It's a data access as well as the availability. So now that we have data ingested from all these data sources to the data warehouse, we eliminate potential errors. And during the data transformation, the business rules are applied, which improve the data quality, and we have acceptance from the business. And we have a superset of data which can be released at any point of time. And we have a single source of truth for the data. Now that the data is loaded into the integrated data warehouse, We can do subject selection as well as the data element selection directly from the warehouse for research data release. Now we will look into the business intelligence data warehouse reporting system, which we have built on top of our warehouse, which supports the research projects, data extraction. So we are using SSRS reports for this particular report. In our reports layer, we have BI data reports per business processes. And here we have configured the data access on the roles and permission basis. And also in our business intelligence layer, we have categorized our big data sets, for example, the survey questionnaires and the lab results, so that we can easily perform filtering to only extract the data elements of interest. When our researchers request for data and samples with specific inclusion and exclusion criteria, and these criteria we apply on the data warehouse, we perform the subject selection, and then we extract the data from these reports for these subjects. We will have a demo of this system soon, where I will show you the reports. Once we have the data downloaded from our reports, we will do de-identification of the data and samples using the pseudonyms, which is generated from our LIMS system. And also we do pseudonymization of the DICOM images. We have in-house developed tools, which is used for this particular need. And also we have BI visualization systems in Qatar Biobank, which is used by the upper management for decision making, as well as which are used by some of the teams in the Biobank for performance measurements. They are mainly used by medical office and clinic team, and then the participant dashboard is used by the management. There you can see the participant distribution per gender, age, nationality, and various other attributes. Now we will go into the demo of these two systems. Please give me a moment to log into these systems. Yes. Now you can see our Power BI report server SSRS reports. This is wired on top of our data warehouse, where we have configured reports per business processes. For example, now you can see that we have instrument measurement reports, we have carotid report, and we have reports for IDEXA scans. Then we have reports for questionnaires, proteomics, metabolomics data. And then we have reports for the electronic medical records data, and also the various lab results which we are receiving from the hospitals in Qatar. We'll go into one of the reports to see the data fetched from the data warehouse, where we have done the subject selection and we have configured and loaded subjects for a particular project. Our researchers request data in a timely manner. For example, now we will see one project where we have the initial request for around 200 participants data. They may request for supplementary data later on. So initially, we will provide the available data. So the report is configured in a way that we can select the studies. For example, this particular project is requesting data from 2 studies. This is the cohort study as well as the COVID study. And then we can also select from which all visits this particular study is requesting for data. So we have selected the baseline and follow-up study of cohort as well as the month 3 of COVID. We will select few of the instruments from which the particular researcher is requesting for data. We will look into the bioimpedance, blood pressure, as well as the hips waist data. Now we can see that the data has been loaded. So this is our report, where you can see the minimal information which we provide to our researchers. You can see an internal identifier. We will not provide this outside. This is for internal use. And then you can see the gender, nationality, age, and the study, the visit. Then you can see the particular instrument measurements. For example, here you can see all the bioimpedance measurements. Then you can see the blood pressure measurements such as diastolic, systolic measures. And also finally, you can see the hip waist. Once we have this request, these data can be easily exported as Excel, and we can provide the same to the researchers after minimal de-identification of the data. Now we will look into the visualization system which we have in Biobank. Just give me a moment, so I will log in. Okay. So in the BI layer, we are using ClickSense for our various dashboards. We have on the left, you can see that we have 3 major dashboards. One is used by the clinic team, the other one by the medical office, and then the third one by the upper management. First, we will look into the clinic dashboard. Just give me a moment so that I can refresh.
If I can interrupt here and ask a question if possible.
Yes, please, go ahead.
Yeah, thank you. In King Faisal, we already have the LIS and we have the integration and data warehouse and all these kind of information. Are we talking about, did I miss, the part of the idea of having this demo? Like what we are need to purchase from the department or from the company or the vendor? Is it LIS system or data warehouse? Because we already have all these in King Faisal.
We are not here to sell any product. I'm not sure when you joined us in the session.
I joined from the beginning, 20 minutes late. But in Biobank, my understanding is like dealing with data, in stored in a secure place in a format that meet the requirement of the hospital. Is that my understanding correct?
Yes.
Yeah, but we are not talking about. We are not attend to to see how's the LIS doing, because we already familiar with this. I mean, we already have the LIS, and we are not planning to replace it. Data warehouse, unless if we need to purchase something or to have a software that's serving different samples from the lab samples.
Yeah, I think the target audience and the name of this webinar is basically how to establish IT for the biobank. So it's targeting new biobanks that they would like to establish their IT systems or IT function.
What's a biobank? And if you allow me and ask you this very primitive question, what's biobank? Dealing with what?
Dealing with participants' data and samples, biological samples.
Biological, which is the same like as lab samples.
I don't know what you mean by lab samples. It's biological samples. Now, if you mean lab sample, it is the samples that you send to lab for further analysis, or you mean
any sample? Because any sample, we already have the LIS, and we have the data, we have the samples, and we can in our system we can adopt.
Yeah, so you are in a great position. I mean, you are in a great position if you have all of these things in place.
Yes, it is.
Okay,
it's in the place.
Yeah,
we have Cerner. We have Cerner, as you said. We have ACFA. We have what they call it, PAC systems integrated with the EMR. We have LIS. So what's Biobank? What we are missing part of from the Biobank. This is the missing part for me.
I don't know what you have in particular. And in King Faisal Hospital, you said?
Yes, in King Faisal, yeah.
I don't have exposure on what you have there to tell you what you need to have more.
Dr. Amal, if you answer, what we are targeting Biobank? What's being Biobank؟ معلش لو سألتكم السؤال المفروض أسألكم قبل شهرين.
Sorry, Mr. Abdul Karim, I think for sake of our presentation, there is a last part that we need to present here. And maybe we can postpone this discussion after we finish. There is still one part that we would like to demonstrate related to the dashboard, if you allow us.
Yeah, it's okay, but I mean, the time is allocated, actually, to my understanding, the time allocated for this presentation is 1 hour. So it's already 1 hour late. So it's already now in Saudi, it's already,
no,
it's already 6
hours. Sorry, it seems that there is issue in the schedule sent, but it's 2 hour session, and we are in the second half and the last minute of our presentation. Then we have 10 minutes for a question and answer, so we'll be able to answer all of your questions, promise. Just bear with us 1 more minute.
10 minutes is okay for me, but as long as anybody can answer me what's Biobank after this long.
If you allow me, sorry, I am Latifa Al Hadri. I am the one who is going to be managing the QA session. Scott had to leave for a meeting. So if you don't mind, Mr. Abdul Karim, to allow Sneha to finish her presentation. Then if you have any question we can discuss even after the meeting. I will put there my email address and I can coordinate that. Thank you.
Okay.
Yeah, please go ahead, Sneha. Thank you.
Yes. Okay, so now we will see of the business intelligence visualization systems which we have in Biobank, where we the management and the head are using for staff performance management as well as business decisions. This is the first system. This is a clinic dashboard. Here you can see the various stages which is performed in our clinical information systems, and then the percentage of the stages done by each nurse. For example, here you can see that the personal data verification stage has been done by 35,000 times. If you can, we can drill down to this report. For example, we will select the year 2018. Then you can see how many times this stage has been performed in this year. And then we can also select our nurses to decide to see how many times they have performed, a particular nurse have performed this particular action. Okay, so now we will go back to another dashboard. Due to time constraint, I will only show one report in a particular dashboard. Now we will see the medical review dashboard. So this is used by our medical office to see the statistics of their department. So I will go into one of the reports which they use on a daily basis to look into their statistics. This is the MRS participant review statistics. Once a participant completed his visit in Biobank, our doctors provide a feedback to the participant. So this particular dashboard, here you can see that in 2018, in each month, how many participant reviews has been happened. And in the bottom, you can see the various staff involved in this particular activity. And you can also see that how many reviews has happened before the turnaround time and how many did not happen. And also which are all the reviews happened in which studies, for example, cohort and cubic. And if the result has been collected by the participant or not, and if the feedback has been provided. So, and we can drill down to this report as I have shown. Now we will go to one of the important dashboard which we have in Biobank. These are used for informed decision making of our upper management. Here we have a participant overview. We can see that how many total participants participated in Biobank. We have around 38,000 participants participated in various studies. In the bottom chart, you can see that majority of our participants are from QBB cohort study. Then you can see the age-wise distribution, gender-wise distribution, their ethnicity, nationality, and also you can see the heat map per age. And here you can drill down. For example, if you have When I click on the gender male, all the charts have changed, and you can see the distribution for the male participants only. So the demo has been completed now, and thank you for the time, everyone. Now we are open for the discussion.
Great, thank you so much, Taha. So again, my name is Latifa Al-Hadri, and I'm going to be moderating this session, the Q&A session. First of all, thank you very much, Amina, Samir, Fahad, and Sneha for the great presentation. Actually, it is well illustrated. That can serve as a course for new biobankers. It shows clearly how to build IT for biobanking. Okay, so we don't have enough time, only 5 minutes. So I'm going to just go over the question received here on the chat. Okay. Let me see. First one. Okay, actually, there are some questions from your end, Sneha. It says, you asked Fahad, in case if you receive more than 100 samples, how do you register? This question for you, Fahad.
So we have different options for this. So if you receive samples on plates, from example, we can scan the plate and receive all together, provided all the samples, the type of the samples on the plate are the same. This is one option. Another option is to reduce the data entry. We have the option to import sample manifest. So import the manifest first, and then you just, while receiving the sample, you just need to scan the barcodes. So these are the two options that we have currently for receiving, more than 1 samples together.
Okay, great. The other question also from Sneha is, are you using both iLIMS and Catalyst if you want to migrate the samples to iLIMS to Catalyst? How this feasibility? I mean, Sneha, you can intervene as if it's not clear for Fahad.
Is it clear for you, Fahad?
Yeah. So currently we are using 2 systems, yes, together, but both the systems are integrated. So all the samples that's available in iLIMS can be extracted from Catalyst as well. So both the systems are integrated.
So it has been built in a way that it will be seamless for the end users.
Yeah.
It's not like they are duplicating work in the 2 systems.
Yes.
We phase it in a way it's easy for them to operate seamless without duplicating efforts.
Okay. Thank you. Any question from the audience?
I think Dr. Abdul Karim, he had a question. I'm not sure.
Yeah.
We
yes.
him,
Okay.
so I feel guilty.
Yes.
So can.
Just I would like to mention one thing. It's just all the recording will be posted on our web page by next week, so you get access to those for all the attendees. Okay. Yes. So please go ahead, Mr. Abdul Karim.
Thank you for the presentation, and thank you for allowing for the question. My question is, what's and forgive me for the ignorance, what's the biobank as a definition to you? What does that mean?
I leave this to our director, Dr. Nahla. She's the expert. I'm IT person. I'm technical. I make this happen. That's it. Dr. Nahla.
Yes, thank you. So I think we started, if Dr. Abdul Karim or Ms. Abdul Karim to attend the first session, we defined the biobank and the protocol and what is the biobank. So it depends about and what are the kind of biobanks present as a definition. In general, that it is a biostore with the data. You can store data and samples, correlated quality data and quality samples, and you can retrieve them in a controlled way. So you have different models of biobank. It's either human, animal, plant biobank, and with human, there are different also types of biobank. It's either population-based, disease-based, So it's a lot of a biobank as a definition. It's not only storage of sample, but it is storage of sample and correlated data in a quality and robust way, and and you are capable of retrieving them, because it doesn't make sense that you are storing samples without any correlated data. It worth nothing after that, and it's a lot. It's a great branch, so we can share you, and please look to the first session once it's published. Yes.
Sure. Thank you.
Welcome.
Mr. Abdul Karim, it seems that you didn't or you missed attending our colleagues' session or webinar.
I missed the first 20 minutes because
No. A few days ago.
It was last week.
Last week.
I wasn't invited.
Yes, you missed a lot. It's better to go back to the recording. You will find it really, really useful.
Yeah, because we are at the end of this presentation, thank you again for the excellent presentation. You're amazing presenter. I mean, great illustration, as I mentioned, that can serve as a course. And basically, this is the purpose of these webinars. And this, so thank you again, Qatar Biobank team, all of you, wonderful job. And tomorrow, I mentioned here that we're going to have the last module 5. It's a biobanking services, and it's going to be starting at 8 a.m. EST. So we'll see you. For the one who missed the previous modules, 1 to 4, you will find them in our webpage once we make the posting available. So thank you again, and have a great evening, great day, depending where you are. Thank you again.
Thank you so much. Thank you all. Pleasure talking to you.
Very nice. Thank you. Bye.
Have a good day. Bye.